Well, I hope everyone's having a wonderful Monday morning. After all, you are down here at the Museum of Glass. I do want to begin today's demonstration just by jumping into the action that we're seeing here today. I do want to ensure that everyone here understands what we are working with, especially the heat, of course. Now, this hot shop is quite hot. Due to that reason, some of the key pieces of equipment are like our furnace, where the hot molten glass is being brought out from. Behind this door lies a crucible, a hot pot of glass. On the top screen, we are seeing that diagram, but we're also seeing our featured artist, Brandyn, entering the furnace to gather more molten glass. Now, what we're seeing here is Brandyn dipping the rod itself into the crucible, that hot crucible of glass. By dipping the glass inside it, we can add additional layer. To make something large or something big here in the hot shop, we will take multiple dips inside of the furnace. We need to gather that necessary amount of glass to really build up. Welcome to the museum. We want to thank you for joining us. Again, we are going to be bringing together 3D printed ceramic into the glass world down here. So we're going to fuse them together later on. The final piece will look similar to what you're seeing here, decorative vases and lighting fixtures. But this is far ahead. Today we are concentrating on a lot of experimenting. What we're seeing, and a big difficulty, is the COE of both materials. Now, you're just going to want to crack for the majority of the time, but we're going to be here kind of figuring out what's the best way to prevent them from breaking when they meet and essentially have a product. Now, down in the center, once the glass exits the furnace, it immediately begins to cool down. So we then enter what we call a glory hole, which is the reheating chamber. It's slightly hotter than the furnace at 2300 degrees. It is essentially a round barrel on its side, lined with fire brick made to insulate and keep the heat inside. Now, as we see the glass in the center, it is clear molten glass, but as of right now, we will see just red and orange hues. What we're seeing is the heat of the glass itself distorting any clear or any color that we may have. Later in the process, we'll also dive into deep in how color works, and even with color, it doesn't matter what color we work with, it always looks red and orange. To shape our molten glass, we are using a wet pattern newspaper. Now, we use your ordinary newspaper. We just fold it, drench it in water, and burn right through it. As long as the top layer is moist, it shouldn't catch on fire or leave any residue behind. We're always standing by to blow air, and we can see another professional glassmaker down on this end, Bobby. Now, what he's waiting for is keywords from our gaffer. The gaffer is the person in charge, and our gaffer here today is one of our featured artists, Brandyn, sitting in the center of the hot shop. So he's in charge of creating this whole piece, and notice the hierarchy going on. Now, Brandon's calling all the shots. He's letting everyone know how hot the glass should be, when to blow. Essentially, he's bringing this whole piece together. When we're asked to blow, we're blowing about the same air pressure you use to blow out a candle. Now, it's not a lot of air, but it does vary. If you listen very closely, you can hear the communication going on between the team. Something as simple as blow or blow hard, blow gentle. But typically, we are blowing about the same air pressure you use to blow out a candle. Before we move on into the rest of the glass making process, we create a constriction or a break-off point. It's the closest constriction to the rod, and this is the crevice that we will use later on to break our glass free from the rod itself. So if you're just joining us, welcome to the Museum of Glass. Again, my name is David. I'm going to be your MC here today. If you have any questions, I am more than happy to answer any questions. But one of our other visiting artists, Phirak, down on the far right-hand side, he began the day with preparing a new print down here. Now, this should take anywhere from 20 to 30 minutes for the final piece. If you're wondering exactly what it will look like, well, we do have examples of that print down here, which will be these ending two. To create these, Phirak, our featured artist, is using two different programs, anything from a Grasshopper and Rhino, to design them and create the code to make these. The residency you're seeing here today is between two artists. They're collaborating to kind of make this a success. One does have a glass background, as we see Brandyn down here. And then we have Phirak down on the right-hand side, who has a ceramic degree, but also structural engineering. And we're going to be using both later on to essentially fuse our piece. So the molds that we're going to be using, we've already begun to preheat. We've actually set some of these molds that we'll have here, and you'll see from time to time a glassmaker might pull one out and then place it into what we call the garage. It's a temporary place where we can store glass and keep it warm. But it's also a place where we can really build some heat for some of these. So you'll notice as a glassmaker pulls them off this table, we're going to use these at the end of the residency by all of them. So we're going to begin by pulling them out and preheating them. Now they're being heated up down here about 1,000 degrees. When we're ready, we're going to bring them out and actually inflate inside. By preheating it, we're ensuring that they're not going to crack, not going to break, or anything bad things might happen. It's going to ensure that that ceramic is at a happy temperature before it meets the hot molten glass. And notice this, our both visiting artists go back and communicate. This is what glassmaking and really this medium is all about. It's communicating your ideas. We are going to begin the next one. And again, I want to really push this across all our visitors. We're here to experiment with glass. Just the reason this museum is here, we're here to push the limits of glass as an art form so we can all sit back, relax, enjoy the show. Our end goal in a perfect world would be to create things that you see out in our pedestal, but as of right now, we're really gonna kind of hone in on the skills necessary to build something like that. So we're using this, or I would say this resonating this first day is really one of the first stepping stones we need to take before we get into one of these end pieces. We can notice that the crew will now be using these other 3D printed molds. They are now entering the garage. At that same time, we noticed our last piece, talked a little bit about it, that was designed both in Rhino and Grasshopper. Being 3D printed at this moment, it will be finishing up within 20, 30 minutes. However, there's a few different glass making pieces of equipment. I do recommend the top balcony at one point or another as you sit back, relax, and enjoy the show. Again, I'll just be roaming around the hot shop. I'll definitely hop on the mic as we really prepare for the next piece. We do thank you for joining us here today. We can see one of the glass makers already jumping right back into the action. It's gathered hot molten glass on the end of the rod. Yes, that's the same material it found in your home in your drinking glasses. We are just working with it at a hot molten state, about the same temperature as lava. So at that 2100 degrees Fahrenheit is quite an extraordinary material that we could manipulate using different tools and also blowing air inside the blowpipe to expand the bubble we may have. Well, there is a variety of different things going on here in the hot shop. Down on this end, we're seeing something completely different. If you're wondering what's going on down on this end, we're using masses of glass to replicate this texture that you see on all the surfaces, so this loopy effect. We're gonna try to replicate that by making this glass separately. And so we're seeing the action down here. We have this tube of glass, we line it with a little bit of kiln watch, we bring over glass, and this should make the basic kind of looping effect that we will use later on. Oh, so coefficiency here. So ceramic has a coefficiency of 20. Glass is about the 90s. I believe it was like 93. What that means is that the ceramic, since it has a more moisture content, ceramic does shrink quite a lot. I don't remember the exact number, but I do know that glass shrinks just less than 1%. It's actually less than 0.1%. So it doesn't shrink relatively at all. What we're seeing is the ceramic, when it's heated up, all that moisture is being sucked away, and ceramic is shrinking over 15%. And that's what's going on right here. That ceramic will constrict the glass, and that will cause it to break and crack. Yes, exactly. There has to be room for the ceramic to not collapse, but also it's just that when they meet right on contact, that's really what's going on, is that as soon as it touches it and it shrinks, it's going to pull that wall in, and that wall will crack eventually under all this stress. Exactly. So what we're here doing is a lot of experimenting, figuring out what's the best way to kind of bring these two different mediums on the opposite end of the spectrum together to make a usable piece in the very end. Again, we're seeing some of these amples down here on this pedestal, but this is just merely one of, hundreds of examples or prototypes that the team has done. Wasn't quite successful, so we're going to go back and kind of clean up, decide what's the best way to approach this idea, and what's the best way so we can make a handful of these. Yeah, no problem. You notice down in the center we had our mold. down on the left-hand side down, and we quickly blow air inside of it to expand to all the nooks and crannies that we may have in our ceramic piece. One of the torches we're using here is a propane torch. It's approximately around 2,500 degrees Fahrenheit. It's ensuring that that massive ceramic in the top is soaking a lot of heat in. Since theoretically on the inside, that's pulling a lot of heat in, it's going to cause the glass to crack. So we're preheating that and to ensure that it's absorbing enough energy, enough heat. We then enter the glory hole, which is about 2,300 degrees, ensuring that our whole mass of glass and ceramic is a proper temperature, that it doesn't begin to crack or break at this point. On the top screen, we're seeing a diagram of this chamber and how it works. Now, safety is a priority here at the museum. We always get asked, what precautions do we take? Well, first of all, we don't allow open-toed shoes here in this hot shop floor. You just never know when glass might end up on the ground. So we're always constantly protecting ourselves. We also only allow natural fibers here at the museum. We love cotton. It's just amazing. It allows us to stay nice and cool. But we don't allow polyester in the hot shop studio. And the reason that is because if that melts on your skin, we will have to go to the doctor and have that surgically removed, just because it will fuse with your skin. Another precaution we take is we wear some form of protective eyewear. Of course, we want to protect our beautiful eyes. Glass does like to crack every now and then when you're staring at it, when you were working on it. You just never know. So we always wear eye gear here at the museum. One thing we always get asked is the lack of protection in our hands. We often get asked why we don't wear any gloves or any really big kind of sleeves on our hands. And the reason is that they can actually distract us more than they can help us out. The glass makers down here, like our visiting artist, Brandyn Callahan down here, his body's acclimated to the heat that he's exposed to, which just means he's used to the glass and the heat that we're working with here today. Now we're going to be transferring our vessel onto a different rod. To do so, we have another professional glass maker down on your right-hand end. Now we have Taylor. Now Taylor's shaping the massive glass by rolling back and forth on the steel table. He is essentially creating the new handle. When we're bringing over the new handle, remember it is only temporary, which means it needs to stay on enough for us to manipulate the glass, but not too much where it fuses with the bottom of the piece and makes it nearly impossible for it to break off. So there's a small window to work from. Luckily, Taylor is a professional, so he knows that proper temperature to work from. Here in a little bit, we're gonna bring this rod right on over and we're gonna attach it towards the very bottom portion. And we will later break the rod we now have free. Earlier in this process, we created a constriction, which is the small waist point you see towards closest to the rod. When we're adding a new handle, we're ensuring that it's turning on center. So this piece is turning on the same plane rather than wobbling back and forth on that rod. To break the piece free, we use a little bit of water and then a slight tap. Breaks the piece free, and we can now begin to work on the opposite end. Now, all we did for this piece to transfer it was dip our tweezers in water. Water's extremely bad to hot glass because it can stress it out and cause it to break or crack, causing a weak spot. Well, here at the museum, we have two furnaces where all the hot glass is being pulled out of. It's hard to believe, but even the massive glass we see in the center, at one point or another, looked similar to what you see on your right-hand side of the studio. To really break down the furnace, behind this door lies a crucible. A hot pot of glass is being heated up here at the museum at 2100 degrees Fahrenheit, about the same temperature as molten lava. Now, this furnace is never turned off. It's been on for about 8 years straight, nonstop. It runs 365 days a year. And if we turn it off right now, it would take approximately 1 week for it to completely cool down and then another week to come back to a molten state. So instead of wasting 2 weeks waiting for the glass, we just leave it on all year around. It's been on for about 8 years straight, nonstop, which is just incredible here. The only reason we would ever shut them down is either to repair or get a new one. Here at the museum, we are melting a soda lime glass mixture, and we're seeing down on this left-hand side, this furnace is running low on glass. So we're in the process of charging it, filling it back up with more glass. The glass that we're melting here is produced about 45 minutes north of Seattle from a company called Spectrum Glass Nugget. They specifically produce pellets and cullet for glass makers. This glass is specifically formulated to stay at a molten state for a longer period of time. So from our manufacturer, we're purchasing this small little pellet. Looks like an ice cube. This is what's melted, and again, it is a top secret recipe. We do know the basics of the ingredients they're adding. We do know it's silica sand, the purest form of sand there is. They then add soda ash and lime as a stabilizer in flux. However, we don't know the exact recipe and if they're adding anything else. Recently, the company did sell their formulation for a pretty penny. So this is a 3D printer. We're printing ceramic. This piece will be used tomorrow. So we're gonna blow inside of this piece tomorrow. Ceramic, clay. This machine, we can actually use any type of clay. One of our visiting artists, Phirak, down on the right-hand side next to the annealer, he programmed this using Rhino and Grasshopper. So he did the code to produce these pieces. We're gonna continue to produce all the ceramic pieces. We're gonna be using everything tomorrow. Anything you see printed today will be used tomorrow. This piece should take anywhere from 20 to 30 minutes, up to an, typically, but it can range up to an hour, really depending how complex. The time to actually make them in the computer can also vary. It can be simply as 30 minutes, or you can spend a few hours depending how detailed the vessel may be. So how are you enjoying our vessel down in the center? It's pretty much complete. The next step we will take is to slowly cool it down in the annealer. Now this is also another part where it's really a shot in the dark. Hopefully, if everything goes right, it won't crack or break, but we won't truly know until tomorrow once we open the doors and see how the stress was relieved in both the ceramic and the glass. Again, we are just building upon this vessels. Eventually, we will be adding colored glass. We do want to start off with a little bit of clear to ensure we're happy. We don't see anything out of the ordinary. This piece will now be cooling down in the annealer on your right-hand side. It will also stay in there for an extended period of time. Depending on the thickness of the glass, it will cool down in that oven anywhere from maybe a few hours to a few months. Telescope glass, which is incredibly thick, anneals for weeks on end due to its thickness. Our piece, we're going to take into account that ceramic, since it will cool down differently. We are going to extend the period for around 24 hours in the annealer. Now, typically 10 hours would do great for us, but I do know that they are going to expend that time period inside. And notice this, that both our featured artists are already communicating back and forth what could be better, what could they build upon. Again, we are going to be using color later on in the process. This is essentially just the warm-up. It's the first day of their residency, their collaboration with one another. And so we are going to be building upon all these wonderful ideas. If you haven't had a chance to look up, I highly recommend it. This museum is just incredibly beautiful and gorgeous. We have a very functional shape. Now that the sun is here, now that summer is right here, it's a wonderful time to live in the state of Washington because it's just beautiful. But this hot shop does build up some heat, and due to our cone-shaped design, we can just fan it out. We've created a natural chimney where hot air can rise. In the 19th century in Europe, they would make hot shops that look very similar to this cone-shaped design, just not at this scale. However, this museum was built in this memory of the wigwam burners that once stood here, our old lumber industry. Now, Tacoma at one point was called the lumber capital of the world. At its height, we had 70 lumber mills just in this area. And around here was these cone-shaped designs called the wigwam burner. It's where the lumber industry would burn excess wood. They look very similar to this cone. The closest one to our area is located in Aberdeen, where the lumber industry is still quite strong there. And you can see one of these wigwam burners that stood here. If you're walking across the Tacoma waterfront, there's information boards across that, and one of them talks into detail about the lumber industry and the wigwam burners that used to stand here. If you're walking around Tacoma and you actually see on the ground like a metal medallion, it says that it has a Tacoma seal on it. I just found this out also. That's used to be where one of the factories of the lumber industry used to stand here in our area. Again, at its height, there are approximately 70 lumber mills. Now, with that information, let's just jump right back into the glass making. We see Taylor down here, a professional glass maker. He's already gathered a small mass of glass, and he's gonna blow an air bubble. He blows air through the blowpipe, places his finger over the hole. Since he's created a closed atmosphere, that air has nowhere to go but expand and pierce a small air bubble. And that's the beginning process of our vessel here today. Now, although any old newspaper will do to shape the mass of glass, we are pretty picky here at the Museum of Glass. We do have a preferred one. We prefer to burn the Wall Street Journal, but again, any old newspaper will do. If you have some of that newspaper in your home, we are more than happy to dispose of it for you. Actually, any newspaper will do. So you can always bring it down here, and we will gladly reuse it, and it will take a life of its own, used to create a beautiful piece of artwork. We burn specifically the Wall Street Journal because we have found that newsprint, the actual paper it's printed on, it's really good quality. It doesn't leave any residue. And also the ink, for some reason, just doesn't leave any residue. There is some newspaper, especially if it has colored, might leave something on the glass. It might be a little streak or a little mark. But that Wall Street Journal, man, that's some good quality newspaper there, all right? Do we have any other questions from our audience? Again, my name is David. My favorite part about my job is answering questions. I am more than happy to also share my glass knowledge with you. This piece will be blown into something we are playing around is blowing inside to get this pattern and then immediately breaking the ceramic right after we blow. This piece that you see here was made in that fashion, very similar to these. This is a different type of ceramic that allows us just to break it once it's been blown into. It won't break the glass, but as you can tell, we do need to do a little bit of cleaning to remove any residue that might be left behind. We're also going to be working with different patterns. How you see in this one, it is called cane or a wrap, which is just different forms of lines in the glass. We are going to be playing with that later on also. But notice that we're strictly working with clear just to kind of get our foot in the door, see what's possible and what's not. Once again, down on your right-hand side, we are playing with how to figure out this pattern that you see on some of them, the loopiness effect that's made in the algorithm in the 3D printed printer. We're trying to produce those loops, see what's the best way we can attach them and apply them to the hot glass. At that same time, notice in the center, it's all about teamwork down here. We're seeing Taylor put downwards pressure to ensure that this massive glass doesn't go up in the air. And then we're also standing by to blow air to expand the bubble that we have. I really hope everyone's having a good Monday morning after all you are spending your time here at the museum. And we're really here just to push the limits of glass as an art form, playing it both as a material, but also seeing what can be pushed with it, what can we do. And it's clearly what we're seeing here today. We're seeing a wonderful, talented crew of artists in front of you, but most importantly, you're seeing our two featured artists, both Brandyn and Callahan working in the center, a professional glassmaker, and then down on that right-hand side, you're seeing Phirak. Now, essentially, they're both pioneers in this industry that you're seeing here. What you're seeing in front of you has never relatively been done before. And so we're pushing the medium both as an art form. 3D printed, as you can tell, is quite a newer technology, and it's already being applied into our industry. So again, the two main artists that you see here are pioneers in this industry that's never really been done before. So the molds that you see on our table are the molds we will be using throughout the day. The one that we're printing right now will be used tomorrow. The molds in the front have been pre-fired, and then they are entering the garage a temporary place to store and keep the glass warm. It will preheat here for a few minutes, and then we will bring it out. As you can tell here, the glass makers are preparing to bring it out. One key detail that they're doing, we see Taylor here, a professional glass maker. He's actually elevating the mold on kind of this top corner. The flame is located on this end, which is about 1,000 degrees, but we do know hot air rises. So by placing it on this kind of top portion, should around 1,300 degrees, even hotter than that. We bring it out, and then we can just really blow inside of it. Just like a mold, by blowing, it's going to contract to every single small portion we may have. Now notice the first thing we do is we go back and we torch the ceramic portion. That ceramic portion is sucking all the heat out of our glass. So what we're doing is we're essentially building up heat on that area. If the glass gets too cold, it will actually break or crack. So by counteracting that, we need to torch that, really that ceramic portion. Oh, and look at this. Phirak has just finished up this 3D printing. We started printing this pretty much essentially around we opened, so it took around an hour to fully create this piece. We're going to be using this tomorrow, by the way, if you're interested. We are going to be bringing that together. But notice that our featured artist, Phirak, is already jumping right back on his computer. We're going to begin to print the next one. So we saw the conclusion of the very first one. We're going to go ahead and create the second one. If you're wondering what we are using, we are both using Rhino and Grasshopper, creating the code necessary to create all these pieces. Now here today, we're seeing a collaboration between two different artists, both Brandyn, who's a professional glass maker in the center. He's called our gaffer. The gaffer is the person in charge, and the gaffer will always sit in the center. So the person in charge of making this is Brandyn. We also see our second visiting artist, feature artist here today, which is Phirak down working on this end. Now, Phirak's been in the glass industry for about 8 years now, and he's actually taught the class at Pilchuck Glass School, one of the most notorious glass-making schools located about 3 hours away from here in Stanwood, Washington. Now, Phirak was actually an instructor and taught both ceramics and glass making, kind of bringing them together. He has a background in digital fabrication, and later on in a future date, all of this on a larger scale will be used. Well, we are going to get started on transferring our piece onto a different rod. So we want to clean up the opposite end where the constriction and the rod meet. So one of the glass makers down here, a professional, has created the new rod, the new handle, what we call the punty. We're going to bring the punty right on over and attach that so it'll become the new handle. To break our piece free, we'll use a few droplets of water or a cold tool on the closest constriction you see towards the rod, which is this area down here. We will add a little bit of water here shortly, and it should break it free, allowing us to begin to work on the opposite end. Do we have any questions from our audience? Any questions that we may have about what you're seeing? Yes, all these pieces that you see here were extruded out of this machine that you see here. No, the only difference is some of these have already been pre-fired. That's to minimize the shrinking that may occur with the glass. If it shrinks too much, you can actually just pull the walls of the glass and cause it to crack. So hopefully by pre-firing them, we are minimizing the cracks that may occur. Do you have any other questions from the audience? Any other questions? If you don't, it's totally fine. But I do recommend everyone check out the live glass making from our top balcony. It's a fantastic place to view the live glass making. And we also have some beautiful artwork all made here in-house at the Museum of Glass hot shop floor. Down on this end, we're experimenting creating this pattern that you see on the surface. Notice this loopy effect. We want to make that out of glass. But there's not really any way you can make that out of glass. So we're just experimenting with different techniques. We're creating a lot of new techniques here today also. We're a lot of experimenting. I really want to drive that forward, is that we can't Google anything you're seeing here today. This is all coming out of the minds of our two pioneers. Both Phirak down here has dedicated an extensive amount of time. He's actually moved out here to the Pacific Northwest to continue this sort of collaboration between both mixing glass and ceramic together to make both pieces of artwork work. And so that's what we're seeing down on this end. We'll really be seeing this, kind of figuring out what's the best way to approach this idea of creating these kind of loopy effect. It's going to be an ongoing thing. We might not even get it today, but we do know that all these glass makers will be trying a few different techniques to figure out what is the best way to achieve this look. The piece we have in the center will now be cooling down for the next several hours. Unfortunately, if we leave it out here, the glass will simply get too cold too fast. It can break, crack, and even explode. To prevent it from breaking, we use a little bit of water on the end of the transfer rod to cause a weak spot. With a slight tap, it is then broken free and on its way to the annealer for slow cooling. And just like that, we complete another piece here at the Museum of Glass. But can we give a round of applause to both our featured artists, both Brandyn Callahan in the center, and then Phirak down on the right-hand side. He's been the person really bringing this whole piece together, designing them in Rhino and Grasshopper so we can blow into them. The pieces that you're seeing being made right now out of this 3D printer will be used tomorrow. What's different about the glass that we're working with and what we're printing with is that later on, with this ceramic, we'll be able to blow inside of it, but not actually keep it how you saw on that end. Rather, we'll just break it off right after, which will leave us with the pattern, but without the actual ceramic. You can see that piece down here. We are going to be playing around with that design also, but you are seeing a lot of experimental work here. This has rarely ever been done, mixing both glass and ceramic, especially 3D printed ceramic. So you're seeing two unique pioneers here in this glass field, really bringing both these different mediums together and making them work. What will really happen is that the coefficiency, their expansion and contraction rate are different. And so they will always crack, but yet both our featured artists here today have figured out a way to prevent that from happening. And so we can get a final product. Down on the right-hand side, you're seeing what the last thing will be is to creating vessels, but also light fixtures with that ceramic vibe that you notice down here. Now, we're still a long way from creating something like this. We will also play with color, as you can tell here, but you are going to be seeing a lot of experimental work here today. Well, if you're joining us, welcome to the Museum of Glass. Thank you so much for spending your Monday morning here at the museum. Now that the sun is out, summer is here, I do want to advise everyone that as it warms up in here, we do offer free water. On your right-hand side, when you enter the museum, we have complimentary water. It's very important that we all stay safe and hydrated, especially since you are in the hot shop. It does get quite hot in here, but please feel free to grab water at any given time. If you would like to see the live glass making also without being exposed to all this heat, we have you covered out in our grand hall area. We also have a lounge area where you can sit back, relax, enjoy the live glass making without all this heat that we're exposed to. Now, for our visitors that are joining us, again, my name is David. I'm more than happy to answer any questions you may have about the process you see here today. But I do want to introduce you to the furnace where all the hot molten glass is being pulled out of. Here at the museum, we have two of these chambers or two of these furnaces. Now, when I open this door, it just looks red and orange, but there is so much more going on behind this door. What lies behind there is a crucible. A hot pot of glass is being heated up, holding approximately 1,000 pounds of molten glass. Now, this furnace is always kept on. It's on 365 days a year, which means it's never turned off. But if we decided to turn it off right now, it would take approximately 1 week to cool down and then another week to get back to a molten state. So instead of waiting 2 weeks to use it, we just leave it on all year round. It's been on for about 8 years now, straight, non-stop. Well, we are getting ready to add another additional layer. If we want to make something big here in the hot shop floor, we will always layer it. We can't just go into our furnace one time and make a giant piece. Unfortunately, it will always have to be layered. As we gather a second layer of hot molten glass, we are giving ourselves essentially more material to work from. Now notice that we're letting the course cool down as we see our featured artist, Brandyn, going back in front of the furnace, taking another layer of hot molten glass. Now it doesn't matter what color we work with, even here as we use clear glass, you'll notice that it have a red and orange glow that is not color, but rather just the heat distorting the true color of the glass itself. Now the rods that we use here in the hot shop floor, they're made to prevent the heat building up on the rod itself. They're made out of stainless steel, which is a very poor conductor of heat. However, with that said, you can still notice the heat and essentially the toll that that heat takes on the rods. If you take a close inspection, notice that the tip is no longer shiny, but rather dull gray and black. We're not placing our hand in any of that darkened area zone you see. For our audience, so everything you see here today, or everything you see on this table, we're gonna blow inside of, and then we're gonna place in our annealer, and they should look like some of the light fixtures, some of the vessels we produced today. My name is David. If we have any questions at any given point, I'm more than happy to answer questions. But please sit back, relax, enjoy the show. You will be seeing a lot of experimenting here today. Down on the right-hand side, the glass makers are going to be producing the loopy effect, the rounded texture that you see on all these vessels. That's what we're going to be figuring out down on the right-hand side. In the center, we're going to be making the vessels themselves. Now, the molds were all designed and created by one of our featured artists, Phirak, closely standing by. All these molds are being preheated, so we're entering them into the garage. It's about 1,000 degrees Fahrenheit. We're placing the molds inside of there, letting them heat up. We will then pull them out one by one as we use them. We're going to see that action here right now. We're seeing one of the glass makers beginning to preheat the molds. We see our other featured artist, Brandyn, in the center, heating up the massive glass. We're now going to be blowing inside of one of these vessels. As we see now, our vessel has been blown into. We are using the torch to ensure that that ceramic area is not sucking away too much heat. Now, what's really going on is that that ceramic part is really sucking away a lot of the heat that the glass is radiating off. If we don't torch that, that will suck out too much heat and can theoretically break it or cause it to crack. Well, now that our vessel is fused together, down in the center, we're bringing over what we call a punty. It's a transfer rod used to begin to work on the opposite end of the rod. So with a little bit of water, a slight tap, the piece is broken free, and we can now begin to work on that top half of the vessel. Now, this piece will go through a thinning procedure. Since we created a constriction or a break-off point, we also thicken the glass towards that top area. To thin it out, we will pull that thick glass and eventually trim it free. Now, as we watch the live glass making demonstration, I do recommend the top balcony. It is a fantastic place to view the live action. So the piece that you saw right now was going through a thinning procedure. The very tip of it tends to be thicker, so that's why we pulled it out and we trimmed it free. Any glass that ends up on the ground cannot be recycled. It becomes contaminated with any dirt or debris that might be on the ground, so we'll just simply toss that away. Oh yeah, these are all made 3D printer designed by Phirak down here, also who's our featured artist. Again, he's a pioneer in this industry now because what you're seeing here has relatively not been done before and studied extensively. But yeah, Phirak and Brandyn, both our featured artists here, are experimenting a lot in pushing the medium of this art form. You know, these will be, so some of these are already pre-fired. Then they're being brought up, so we preheat them, and that's what it's allowing them not to break on contact with a hot molten glass. Yeah, it definitely is unique. I've only seen it a few times. Phirak actually taught a class at Phirak Glass School, a notorious glass school around the country. Phirak was one of the first ones to teach a 3D printed class with glass, which is just incredible. Is it a normal 3D printer? This one is very versatile. We were discussing about it earlier. We can load up any type of clay we want inside of there, and it will extrude it. It definitely is a unique process that you don't see too much, and especially like our visiting artist here, I really want to push that point forward that Phirak was one of the first classes to be teaching 3D printed and glass together, which is just a unique thing. What you're seeing here is relatively new. 3D printers are relatively new, and then you throw glass in that mix, and it's really never unheard of. And that's what we do here. We're here to push the limits of glass as an art form. Luckily, we have amazingly talented, skilled glass makers and designers. What's up, man? How's it going? Good. How you doing today? Now that this piece is complete, we will now be cooling it back to room temperature. Sitting on your right-hand side of the hot shop floor, we have an annealer, an oven currently sitting at 920 degrees Fahrenheit, and it will be the home of our vessel and everything we produce here today for the next several hours. And it's due to the glass cooling down slowly that will cause it to break or crack. You need to control that cooling temperature, essentially also for the ceramic to ensure that it's cooling down at a proper rate. Too fast and the glass probably, or the ceramic part will shrink and kind of constrict it like a snake and cause it to break or crack. Just like that, we complete another piece. But down in the center, notice that the team is already jumping right back into the action. Remember that here at the museum, we have 2 furnaces where all the glass is kept itself. We're melting approximately 2,000 pounds of glass here at the museum, all at a molten state. Northwest. I hope you're enjoying it out here. It is a unique area to live out here. As you can tell, we're pushing the limits as an art form. What you're seeing here is relatively never been done before, so it's up to these artists here to kind of figure out what's the best way to approach it and then bring both materials together in one vessel. Yep, so we're heating these up. The molds that you see on this table are going to be preheated in a garage to about 1,000 degrees. We will then bring them out and blow inside of them. So this vessel will meet that similar process. We have the kind of a stair system down on that end. We're going to ensure we get a good view of this. However, these ones will be blown inside and the ceramic will be kept with them. The vessels we're printing today, as you can see, these ones, we're going to blow inside of them, and immediately after the glass is hardened up, we're going to break free that ceramic, and it's going to be used as a mold to create vessels as you see this one. Now, we're still a long way away from that. Right now, we are experimenting a lot, figuring what's the best way to approach this. What you're seeing here is relatively new. We have two pioneers, both Phirak, focusing a lot on the printmaking aspect of it. I mean, the 3D printed aspect of it. You can see him going back and adjusting them, figuring out what the right proportion, the right way to figure this out and make everything come together successfully. Down on the right-hand side, we have another project going on, but this is very similar. We're trying to figure out what's the best way to create the looping effect. If we all see these pieces, notice that there's kind of a looping texture on them. We're going to try to figure out what's the best way we can approach that and bring it to the hot glass. So down on this right-hand side, we're just going to be practicing with different techniques. Down on the center, however, the crew is really focused on creating these vessels. Now remember, we're entering a chamber that's approximately 2,300 degrees. It's hard to believe this, but the glass you see on the end of the rod began at a molten state in our furnace. The furnace holding approximately 1,000 pounds of molten glass. Behind this door lies a crucible where all the hot glass lives and sits at. On our top screen, we're seeing a diagram of the furnace to furthermore explain what's going on behind the door. Now, it just looks red and orange, but there is so much more. In the diagram, you can see that behind sits a ceramic pot. A crucible of glass is what we're heating up here, and that is how we're gathering the hot molten glass, by dipping inside of that pot. We then go back and manipulate it, shaping it using different tools like a wet pad of newspaper. Now, that's the old Wall Street Journal, folded up, drenched in water. We burn right through this newspaper. It's okay, though, we recycle it. If you have some of this newspaper, we'll bring it down here to the museum. We're more than happy to recycle this newsprint for you. As long as we keep that top layer moist, it should prevent it from marking the glass or even catching on fire. The chamber that we're entering is slightly hotter than the furnace at 2,300 degrees. We can see this one already starting up. How impressive is that? Going back to this action that we see in the center, it is hotter than the furnace at 2,300 degrees. Now, Brandyn, our featured artist today, one of two, he's heating up that bottom section of glass. Now, that tube area, the neck area, is complete. We're going to go back and manipulate that later on. As of right now, we're really going to begin to focus on that edge, and we'll see a lot more red and orange. At that same time, another glass maker on your left-hand side has begun to preheat the next mold we will be using. We sit them in the garage, a temporary place to store glass, keep it nice and warm, or a place where we can even preheat anything we wish to use. Now, it's sitting in this 1,000 degree Fahrenheit side, about 537 degrees Celsius. We're shortly here going to bring it out, lay it right on the ground we're going to begin to blow air and inflate the massive glass behind this ceramic portion. Now, we are working with clear glass here today, but remember, eventually we will be moving on to colored glass. This is an experiment. We are testing out different pieces of glass and what is really the best way to approach this. Oh, so this yellow canister, now that is a map gas. It's a torch that's even hotter than this flame. That torch is well over 3,000 degrees. It's just a tool used to heat up one specific area in the glass we wish to manipulate. Thank you so much for joining us. Welcome to the Museum of Glass. My name is David. If you have any questions, I'm more than happy to answer questions. Of course, though, we do have a professional crew behind me. Now, they're talented glassmakers. They know how to work with. And our two feature artists here consist of our gaffer working in the center, Brandyn Callahan, and also Phirak, who's standing closely by. Now, once again, the pieces that we're printing out here today will be used tomorrow. But we can always watch that process going on. Well, now that we've transferred our piece onto a different rod, we're going to begin to work on the opposite end. Now we bring over what we call the punty, which is just the transfer rod. It's a new handle on which we can begin to work with. We go through a centering procedure. This is to ensure that the vessel is turning on the same plane rather than just wobbling back and forth on the rod. The rods themselves are made out of stainless steel, which is a very poor conductor of heat. So the heat is not being transferred all the way through the piece itself. Rather, it just stays right on that very top portion. If you take a close inspection, you can begin to see that the rod is taking a lot of the beating, but nearly towards the tip of that rod, where the rod is no longer shining, it's turned black and gray. We're not placing our hand in that area, rather it's directly behind it. Again, my name is David. I'll be roaming around the hot shop floor. If you have any questions, I'm more than happy to answer questions. I'm also more than welcome to share my own glass experience. However, I hope everyone's having a wonderful Monday afternoon. It is an incredible time of the year. It is summer. We're here, and it's beautiful weather here in Washington. I do want to advise and let everyone know that we offer complimentary water. When you enter the museum, on your right-hand side, there is water. Please feel free to hydrate at any time. It's very important that we all stay safe here in the hot shop floor.
.3D printer, yes. Yes, ceramic. Oh, yes. So this is Phirak's own machine that he brought over.
So the 3D printer that you see here is made out of ceramic, and it was brought by one of our featured artists. Phirak is down here now. Phirak's been in the glass world for well over 8 years now, but he's here at the museum continuing this exploration of both ceramic and glass being brought together to make a piece. Again, if you're thanking us, welcome. If you're joining us, welcome to the Museum of Glass. Thank you so much for joining us. I'm going to be your MC here today. My name is David. I'm more than happy to answer any questions you may have, but I hope everyone's having a wonderful day. If you haven't had a chance to look up, I highly recommend it. This museum is in this iconic cone-shaped design. Around the 19th century in England and around Europe, they would make studios, hot shop studios, that would have this similar cone-shaped design, which is very functional, where hot air can rise and it's sucked out by the fan we have on the top. Which is one of two reasons why we have this cone-shaped design. Real quickly, to put into context of everything we are working with here today, the glass, it's hard to believe this, but the vessel that you see in the center, all that glass portion was pulled out of our glass furnace. We have two furnaces here at the museum holding 1,000 pounds of glass. The glass that we melt here at the museum is produced and it's made about 45 minutes north of Seattle. We are currently melting what we call Spectrum glass nugget. It comes to us in a pellet-looking form. This is what we're filling our furnace with. This will melt overnight and become the glass that we use. This glass is made out of silica sand, soda ash, and lime. We do know that's the basic ingredients, that's the glass that we use here. However, we don't know the exact recipe. Recently, Spectrum did sell their cullet, the actual recipe, for quite a lot of money. So this will be produced, I believe, in New Mexico now, the company that just bought it out. But essentially, this glass is formulated to stay in a molten state for a longer period of time. All this means is we have a longer working time. It will stay hotter and stay more malleable. Yes. What do we use the color? So today we're working with clear glass, but if we wanted to work with colored glass, we would apply it separately in what we call a color bar form. I'm gonna pass this color bar around, right? So I'm gonna start it from the front row, and then we're slowly gonna make our way everywhere. The solid color bar is made by adding different metals of the periodic table of elements. If you don't mind me asking, what's your favorite color? To blue glass. Oh, I love blue glass too. To make blue, we would add cobalt. It's specifically metals. If you like green, we might add chromium or iron. If you like red and pink, well, you do have expensive taste. Both red and pink are made from gold, which makes it some of the more expensive color in the glass industry. You are paying for the gold content. We even use uranium in glass, which produces a glow-in-the-dark green. But again, it's specifically metals that will give us colors. Now, the way that we apply colors, we actually create a thin layer of color that will be sandwiched between clear glass. We call this a color overlay technique, and most glass you have in your home is probably playing the same trick. It's not solid color. The reason why we're purchasing this bar form of color is by melting clear glass, we're giving ourselves the ability to use the full color spectrum rather than one or two colors. This piece is going to be put away and it's going to be entering the annealing oven. The oven on your right-hand side sitting at 920 degrees. It's slowly going to cool for the next few hours to ensure that the glass won't break on contact. I do want to show you exactly how the color is applied. So I'm going to be showing you a color overlay video on our top screen. Rather than me explaining it, I want to show you exactly how it's done. It is a unique process because, again, this is most of the glass in your home is probably colored the same way. So on our top screen now, let's get our color overlay video.
The color in glass comes from adding various materials to the mixture of raw ingredients called batch. Most of the colorants are compounds containing some kind of metal. For example, adding cobalt to clear glass creates a deep blue. Tin and antimony can be used to create white glass, and gold chloride can produce a rich red or pink colored glass. Colored glass is melted in furnaces, just like clear glass, and then is usually rolled into bars for storage and easy application. In order to apply color bar to a bubble, we first need to preheat the color to approximately 950 or 1000 degrees Fahrenheit in a color oven or garage. Once warm, the color is then picked up on the end of a punty rod using a little bit of clear glass as a support. The color is then heated in the 2300 degree glory hole to soften it and make it malleable, while another artist creates a small bubble of clear glass on a blowpipe. Once warm, the color is dropped over the clear bubble, and then using a variety of hand tools or the steel marver, the color is rolled back over the clear in an even layer. This process is called dropping color, or creating a color overlay. Depending on the project, that bubble is then usually gathered over with clear glass and blown into the final form. The finished product may appear to be all made from colored glass, but when viewed in cross-section, we can see that there is only a thin layer of color sandwiched between many layers of clear glass.
Well, in that video, we saw that coloring application. Again, most glass in your home is probably playing that same trick, which is just unique. We have that color cut section here, and it's just fascinating to know that even all the glass in my home, before I became a glass maker, was doing the same thing. Even for me, it's kind of hard to figure out if it's solid color or if it's this color overlay trick. You can only tell if the glass has been chipped or broken, but at that point, why would you want that glass any longer? So here today, I do want to spend a second in talking about one of our key featured artists. Now, that is Phirak. Now, Phirak has been working with glass for well over 8 years now. And what I want to kind of get here is that Phirak does have a background in ceramic, but he also has a background in digital fabrication. And he's been using Rhino and Grasshopper to produce everything you see here. What Phirak is doing and has been doing, he's taught a class at one of the most prestigious glass schools called Pilchuck Glass School. It's located about 3 hours away from here. And Phirak is essentially a pioneer in this because no one is doing this how he is doing. He's actually moved back to Seattle in this area to continue this journey. And again, I really just kind of want to put that through to our audience just because we can't Google anything that you're seeing here today. A lot of it is coming through experience. This residency and our two key artists here are both Phirak, but also Brandyn working in the center. This is a collab that they're having between one another. But if we can give them two a round of applause, I really appreciate that. They're amazing artists, and they're really here pushing that limits of art and glass and ceramic and bringing them together, which is just unique and one of a kind. And with that, notice that the glass makers, they're already just jumping back into the glass blowing process. I mean, they're just continuing the hard work and dedication. And this is what this museum is really built after, is creating this communication for artists to have the ability to continue their exploration of artwork. Traditionally, so what we're seeing here, glass blowing is all based off of Italian glass making. American glass blowing is resembling Italian. And actually in Italy and Murano, they actually don't allow women to blow glass. Here in the United States, however, we've had an increase. Pilchuck glass schools and a lot of glass schools around have taken upon them to be having a lot of women in this field. It is dominated by males, the glassblowing industry, but that is changing. Here at the museum, we have an incredible crew. I mean, one of our main glassmakers, our gaffer, her name is Sarah Gilbert. She's one of the most talented women glassmakers out there. I mean, she was asked by the GAS conference, the semi-annual glassblowers conference, to give a demonstration out in Murano, Italy. She's one of the first, and we're proud to have her and be one of the key members of the Museum of Glass. The glass process that you're seeing now is being cooled down. So this rod is made out of stainless steel, which is a very poor conductor of heat. So it doesn't allow the heat to be transferred all the way through. So we're using a pipe cooler, which is cold water. We run on the surface of the rod, which in turn just cools it down, making it easier for us to handle and manipulate that mass of glass. Now remember, it's coming out at a molten state around 2100 degrees. That is incredibly, incredibly hot, but it's hot enough that we can manipulate using different tools. The wooden blocks that you see are made out of fruit wood, and we prefer to burn fruit wood than any other type of wood, just because it contains more moisture, and it doesn't burn out as badly as any other woods that we may use. An added bonus is that it smells like barbecue when it's burnt. Than any other type of wood. And then when you see the blackness, that's the chard. That's actually the wood's natural response, so it doesn't burn or catch on fire, essentially. Yes. And it does smell like a barbecue when we burn it, which is always a pleasant smell, of course. It smells like a barbecue. And it is a mist of summer, which is always pleasant, right? Well, all around this hot shop, we have these steel tables we use for shaping the massive glass. The steel tables were traditionally made out of marble, and that's where we get that name marver from. We call it marvering when you roll back and forth. Nowadays, though, you don't really find a solid slab of marble. It is quite expensive, but it can also crack under enormous temperature. In some studios, every now and then, you'll find a piece of marble, but it's just a cracked slab, and it's very small that they can use. Of course, one of the most important shaping tools is the wet padded newspaper. Now, although any old newspaper will do, we are pretty picky here, so we do prefer to burn the Wall Street Journal, but any old newspaper will theoretically do. We burn it for a few different reasons, but it's just a really good quality newspaper we burn. Now, as long as we keep the top layer moist, it should prevent it from breaking or cracking. So what we're doing with these ones will actually be broken off. So what we're going to be doing is we're going to be blowing inside of them, and then right after they're blown, they're going to be broken up. So we don't need to fire these, since these will be just broken up. What we're doing is to create the vessel itself. What you're seeing that is also this one down here. Right after it's blown inside of it, we will crack it, break it open, remove all the ceramic, and then we begin to reheat it. Again, this is just a small step of many to come. Eventually, we want to make something that it's easy and versatile to produce. These can overnight. Oh no, so what we're going for here is only temporary. Remember, it just needs to hold together while we blow the glass inside of it. After that, we're gonna chip it away right away. So we only have a few minutes to break it free, so if we actually harden it, can become difficult. So the pieces that you see made here today, they will not be sold. We're experimenting a lot. Everything that's produced here and through this residency, both Brandyn and Phirak will take home back to their studio. All we ask of our visiting artists is to donate 2 pieces, one to our annual gallery and one to our annual collection of glass. Other than that, it will all be sent back to their studio. I also want to let our audience know that we're going to be having a docent-led tour of our gallery at 1 o'clock. I highly recommend it. If you want to leave the museum full of knowledge about what we are doing here and the artwork we have, at 1 o'clock, we're going to be having one of our wonderful docents be giving a tour. If you want to be part of this, just meet our docent right on the donut where you entered the museum and you got your pass to enter. Just meet him right out there, and you're going to have a wonderful time, I guarantee it. If you want to stick with us, you're more than welcome to do so. We're going to continue to blow glass either way. Well, we have our massive glass blow now here in the center. We're going to be entering an optic or the mold that we have. So all these pieces that you see here on this table, we will be going through. So notice that one by one, we're going to be pulling them out. We're heating them up in a garage, which is a temporary place to store the glass and keep it nice and warm. It will be brought up to about 1,000 degrees, and then we can attach it to the glass. So these pieces will stay on there, and they'll look very similar to these lighting fixtures and also these vessels that we will make later on. We are working with clear glass today because we're just trying to figure out some of the key things about mixing glass and ceramic together. By the way, it doesn't like to be together because they tend to break and crack, but we're going to get around that by making the annealing cycle longer, but also just the way that the bubble is blown out. So we can see the crew has already pulled out one of these molds. We see our featured artist, Brandyn Callahan, in the center, coming right over to the mold, blowing inside of it, filling it to all the small nooks and crannies. And it's due to the texture of the ceramic that's allowing it to stick to the inside. Well, the glass that we melt here at the museum is specifically formulated to stay at a molten state for a longer period of time. Now, down on the left-hand side, we have another furnace that's about the 2100 degrees Fahrenheit, but this one is actually running low on glass, so we're in the process of charging it, filling it back up with more glass to use tomorrow. The glass that we melt here at the museum we purchased from a manufacturer called Spectrum Glass Nugget. It's produced about 45 minutes north of Seattle. It's a local nugget that we're melting, but it's meant to stay at a molten state for a longer period of time. All this means is we have a longer working time with our glass. When we're charging our furnace, we actually bump up the temperature, so it's around 2200 degrees. It's extremely hot. If anyone brings in their lunch, we can reheat it in the matter of seconds. I mean, if we leave it there for more than a minute, it'll actually catch on fire. Down in the center, the next step is to bring over a transfer rod, a punty. It is going to be the new handle on which we can work with. And this way, we can now begin to work on the opposite end, and now that's going to get started here shortly. Again, my name is David. I'll be walking around the hot shop. If you have any questions, please feel free to ask. So, yes and no. These ones, however, they will stick like that. You're not going to mess with them. It's these ones that will actually break the outside texture. We're just using this to create the foam itself. Not really worried about the pattern. What we're actually doing on the right-hand side is actually producing this kind of movie effect that you see in all of them. We're going to try to recreate that surface texture. Well, this piece is just about complete. The next step we will take is to slowly cool it down in one of our annealing ovens. The annealing oven is the oven sitting on your right-hand side of the hot shop floor with the green number 4. It's currently sitting at 920 degrees, and it will slowly cool our massive glass for the next several hours. So down here we have Bobby, who's suited up in a heat protective layer. He's wearing the same things firemen and women use to combat fires, Kevlar gloves, with a few droplets of water on the crevice and a slight tap. It breaks our vessel free, and we will now be cooling it down for the next several hours. And just like that, we successfully put another piece of ceramic and glass in our annealer. Let's give this crew a round of applause. They just did an amazing job. Well, this concludes our morning live glassmaking demonstration. From everyone down here at the museum, we'd like to thank you for joining us. The glassmaking will resume in about 1 hour when we come back. If we have any questions, right now is a good time before we head off. If not, definitely enjoy your day.